Great. Hello everyone. Welcome back to another tutorial. In this tutorial, we want to work with the Ansys Workbench to use the FEA feature of the Ansys. So what I want you to do, please go and open the Ansys Workbench. You can either search for Workbench into the Start menu to open up the file, but the Workbench is part of the Ansys software. And you can see within the Workbench, it's a modular software. We keep leaving the software, the main Workbench software, and go to the different Ansys, basically product and software, and we'll come back to it and we'll see what I mean by that. So if you look at the software on to the left hand side, you see I have a toolbox which basically give me access to different range of the analysis, whether for instance you want to do a thermal analysis and a static structural analysis and so on. You will have access to all of them in here, and you will see your project there. If in case you want to create a new project, you can go to the file and click on new, or you can use the control and shortcut to be able to open a project. Already create a new project, and you can see that's the project that I have. In here, basically it shows the project schematic, every single stage that I want to do, it will appear here. So in this case, for today, we want to have a static structural. And what you need to do, click on a static structural in here, which let me zoom in. So click on a static structure because we want to do a static analysis. And now drag it down and drop it to the project schematic. But you will see now I will get that static structure block. If in case I'm gonna bring the new block again, I can either drag and drop it like what I've done, or what I can do, I also can double click on it. It's the same things. And you can see the benefits of this software is you can have the different analysis all together to run parallelly, or depends on the result of the other one, which is why the answers become quite well known in the FE analysis. So let me get rid of these. Any of these you don't want, you can right click on them and you can delete them. So let me delete this one as well. And we will have only one block. So in the block A, you can see the type of it is structure, static structure. If in case you want to rename it, you can double click in here and you can put whatever name you want to put here. For instance, I want to put, let's say, a plate analysis. So we write plate analysis and I press enter. So you can see the name of it become the plate analysis. In order to save it, I can either click on save here, or I can do a Control S, which save the project for me. So make sure you save it in your local drive. In this case, I'm gonna go to and save it to my desktop. And what I would recommend you to create a new folder for that. I'm gonna call it the plate analysis, and I will tell you why, because you will see once I save everything, it will get a few files in it. So I highly recommend to save it in a folder. I'm gonna save it as a plate analysis project file, which is the Ansys file, and click on save. So make sure you save it on your local drive. If in case you are using the computer, the university computers, make sure you don't save it on the C drive and save it on a local drive, because otherwise they might wipe out the C drive and the temporary file after a period of time. So you can see that everything is saved, and I have the plate analysis here. It says static structure, and now the software asks me to specify what material I want to use, because every single material has a different properties that I need to define here. So what I need to do, I need to double click on the engineering data, and you will see I go to this window, which basically is the engineering data for different materials. By default, software choose the structure steel for me. And if I want to bring another material in here, what I need to do, I need to click on the engineering data sources. So make sure you click on the engineering data sources in here. And once you click there, you can see bring the list of materials for me. So the list of materials, the first one the first basically a window. If I scroll down, you can see I have access to the general materials, the additive manufacturing materials, composite, and so on. So I have to decide which of these materials I want to use. In this case, I'm going to use a general material. So what I will do, I will click on the number 4, which is general material. As soon as you click there, the second window will then change and bring the materials that they are into the general materials. One of the benefits of using Ansys, it has a wide range of material in their library, and usually they almost have every single material you ever think about in their database. Also, you can create your own one, which put a different kind of, the yield pawn, modulus, Young modulus, and so on. So in here, let's use the stainless steel. What I will do, I click on it and click on the plus, or basically add it to my engineering data. So now if I click back to the engineering data sources again, you will see not only I have a structure steel, I also have the stainless steel that I just created. Once you're happy with everything, what you need to do, you need to also think and double check your values in here. The density, the isotropic elasticity, the yield strength, and so on. You can see each of them, they have a different one. And if I want to modify that, I can click on them and modify them. So in this case, I'm going to go everything by default, so I don't mess up with here. And what I will do, I close the engineering data. So on the top, click on close, and I close the engineering data. So what you will see in front of the engineering data, there's a tick, which means that I have specified the material I want to use. So the software asks me, you've done the first, which was basically define what analysis you want to do. You define the materials for me, but you still haven't defined the geometry. You can see the Ansys is trying to help me to tell me what kind of, things I have to specify in order to run the FEA analysis. So click on the geometry, right click on that, and you will see I can import the geometry, which basically I can design it into the other softwares. I can either use the Ansys design modeler, or I can use the other software such as SolidWorks, such as CATIA, such as the Siemens NX, and import the geometry. I personally use the other software such as the CATIA, Siemens NX, or SolidWorks design model because I'm comfortable with that. But if in case you want to use the Ansys solution, whatever through the Ansys software, you can click on the new design modeler geometry, which basically use the Ansys design modeler to create a geometry there. And this is what we want to do for this tutorial. So hopefully you can learn also how to work with the design modeler using the software. And you can see the design modeler is going to start. So onto the bottom left, it shows you that what's the software is working with. So it might take a few seconds for you to open up the model. So while you're into the software, you can see that you will see the name of the project is a plane analysis. You will see the different planes, X, Y, Z, X, and Y, Z planes, and also whether you have a part of body here. You will see it in the sketching and also the modeling here. So what you need to do first, you need to make sure what units you're working with. So go to the unit, and in this case, I'm gonna use a millimeter. So click on the millimeter to make sure you're using the same units that I'm using. And now what I will do, I will click on the XY plane. So now what I want to do, I want to create a new sketch. And in order to do that, make sure into the XY plane. So the XY plane will appear here. And you need to click on here, which says create a new sketch. So let me zoom in so you can see it better. What you need to do, you need to click on here, which basically is creating a new sketch. So once you create a new sketch, you can see the sketch one will appear here. However, I don't have a normal to view. In order to have a normal to view, what you need to do, you need to click here, which says look at the face. And what it does, I will get a normal to view. So let me zoom in again so you see it better. You need to click on here, which says look at the face or the plane of the sketch. Once you do that, you will see that you get a normal to view. What I want to do now, I want to click on the sketching here. So click on the sketching, and you can see you will get these different basically the menus, and I'm sure you're familiar with it because it depends on what software, what CAD modeler you used before. It's quite similar to those. You have a draw, which basically you can use the line, a polygon, rectangle, circle, and so on to create a model. For this tutorial, I want you to click on the rectangle and click on the coordination systems, absolute coordinate systems, and drag it down and make a rectangle. So what you need to do now, you need to apply dimensions on it, and in order to apply the dimensions from the draw, then I move to the dimensions, and I want to use the general dimension. Click on the general, click on the lines you want to get the dimensions, and put it outside the model. So you will see in my case I have the H1 and the V2. So the value of the H1, I want to put it as the 200 millimeter. So let me change this. I will wipe it down. It's a 200 millimeter. And the value of the V2, I want to put as a 50 millimeter and press enter. So now what you will see that I have basically a rectangle with the 250 millimeter. So you see the 250 that I have it here. Now I want to draw a circle in the middle. So what I will do, I will go back to the draw. I will click on the circle and I'll draw a circle in here. And what I need to do, I need to go to the dimensions, click on general. First of all, let me give the diameter of this one, which is D3, and I want to put the diameter of the 25, for instance. You can see now become 25. And now I'll click on the center, on the side, bring it outside, which basically for me become L4. In your case might be different. Alphabet, I will put it as 100 because I want to bring it to the center. And the same things from this point to that line to the side, and I want to put it as the 25 to bring it to the middle. So once I finish everything with the 2D level, what I need to do, I need to either hold down the scroll button and rotate the model to the 3D geometry, or you can click on the rotations on the top. And whenever you want to have a fit to, which basically if in case you don't see your model in full, you can click on here or can use the F7, which is zoom to fit. Once you do that, I want to convert the 2D model or 2D geometry to 3D. So what I need to do, I need to go to the modeling. And to the modeling, I will then click on the extrude on the top. So click on extrude, or for instance, extrude if you're coming from the Siemens NX or SolidWorks. We are familiar with extrude. If you're coming from the CATIA, we call it pad over there. So you can see the geometry is already selected, and I click apply. So the geometry is selected. However, the depth of that is 30 mil. I want to change it to 5 mil and press enter. So what you will see, a geometry sketch. I select it, I click OK, the depth of it, I put the value, but I don't see the model because it's not generated. So the answer is every single change you need to do, then you need to basically generate it. And also you can see the software tells me I need to generate that. In order to do it, I'll click on the generate, and what you will see, it will convert the 2D model to the 3D model. Now I have a 3D model, everything is fine. If in case you want to save it again, click on save. And what you will see, I don't save it as a separate file. Still, will save it in the main project that I've done. So it's a one file which has everything, every single thing I defined, from the analysis type to the material, also to the geometry that I have. So once you finish that, minimize this one, and we will come back to the previous block that we're working with. So you can see that's why when I was talking about the Ansys, I said it's the modular software. So it goes out of the software, go to the other software and come back to it. What you will see now is a static structural, the engineering data is tick, a geometry, there's a tick in front of it, which means that I have done everything. Now I need to go to the number 4, which basically is a model. Within the model, what I will do is basically will activate the mechanical interface, and basically everything from level 4, 5, 6, and 7 would be down in one go. So what you need to do, double click on the model, And you will see that now it take me to the other part of the solver. Again, you will see the basically the mechanical interface is going to open for me. It might take a few seconds, so let's wait for that. So now you can see that basically the mechanical interface has been opened. So what I need to do, I need to click on the geometry in here on the bottom. And once I click on a geometry, if I go and select the geometry in here, the geometry will then appear. So I can see the geometry has been loaded and there's a tick next to it, which means that I have a geometry. And if I click on a plus, you will see that's a solid model. So that's a solid geometry. The material by default in here, however, is a structure still. So if you click on the geometry and if you go and click on solid, you can see here, let me open this one for you, you will see that basically is a structure still. If you want to change that, what you need to do, you need to click on the arrow next to the structure still, and then depends on what material you imported from the beginning, you will see them here, and you can change it. For instance, if I want stainless steel, I will change it to the stainless steel. But to be honest, for this tutorial, let's keep it as a structure steel. I just brought the stainless steel to tell you how you can load it, but in here, let's go with the structure steel because that's fine for what I want to do. And you can see it's a tick next to the geometry, and these are the material I imported, but I use the structure steel only. However, if I go to the next stage, you can see my model is not discretized, so I don't have any mesh. So what I need to do, right click on the mesh and click on generate mesh. What it does is software goes through and find out the best size of the mesh and apply for it, which is why the Ansys is quite well known and to use in industry because they have a really good system to find out the appropriate mesh. And you can see that's the mesh that it generated for me. If I want to modify this mesh, however, I can go and right click on the mesh. I can go onto the insert and you can see all the refinements I can work with. I can change the method, I can control the sizes and so on. What I want to do, I want to click on the sizing and I need to specify what geometry to use. If I want to select the geometry, you can see it only select the faces for me. So in order to select the full geometry, from the tab in here, go and click on this one, which is body. And now I can pick the full geometry. These are all filters. And now I will click on apply. So you see it has the one body, but the element size is by default 1.02 meter. You can see the unit in here is a meter. To change the unit to millimeter, because we work with the units, go onto the top which says quick launch. Into the quick launch, type unit, and then convert the units to this one, which is the millimeter, kilogram, and newton. Click there and it will convert the units to the millimeter. You can see it's 10.27 millimeter. This is what the software recommended. But let's increase the quality by changing the size to 5 millimeter. So from the 10, I will do 5. Click enter. And you can see nothing is changed. However, the mesh shows that sign, which means it's not updated. So in order to update the mesh, what I will do, I will right click on the mesh and I will click on update or the generate mesh. In both cases, it's the same thing. What you'll see, it basically goes through and I will get a much more refined mesh. So let's go back again. I will see my model, a geometry, a tick next to it, which means it's done. The material is done, the coordinations, and also mesh is also done. You can see how Ansys is trying to help me to give me every single steps I need to do. So I went to the much more refined mesh, and now what I want to do, I want to tell the software what are the forces and what's the boundary condition, what are the loads and the boundary condition. Into the static structural or the analysis setting, both of them is the same thing in here. You need to go there, click there, analysis settings, go to the environment. You can see any of these ones I click, basically the menu bar on the top would then change. So what I want to do, I want to go to the analysis setting. I will go to the context or environment. And within the environment, I will see the loads, I will see the structure supports. Let's go and start first with the boundary condition. I want to fix one side of the model that I have. Let's fix all the face in here. You can see that from the geometry, I select the face and I click apply. So all the face, every single elements of these mesh in here has been fixed. So it would be no movement in X, Y, Z, basically no translation in X, Y, Z, and no rotation in X, Y, Z. So I fix everything in here. And that's what we call it by the fix support. Now on to the other side, I want to put a force in here. If I go to the loads, you can see these are the type of the loads that I can put here. The same things, different kind of supports, they're all appear here. And these are the most common used, basically, support and most common used loads. In here, I'm going to use a simple force. I'll click on a force, rotate my model by holding the scroll, or we can use the rotate is the same things. You can use the rotate, for instance, in here is the same things, and click here. And now click apply. So you can see from the geometry, this is the area I want to put the force. However, from here, from the vector, right then I get the arrow, I want to control the amount of the force that I put in X, Y, and Z. So what I will do, I will click on that arrow and I will go to the components. This will enable me to put the values for X, Y, Z. What I want to do, I want to get the force in here because I want to pull out the model. In my case, become X. In your case, become different because it depends on what plane you started to use. Because I use the XY plane, this is the direction of X. So the X, I put the value of, let's say, 1000 newtons, and I press enter. So what you will see in the X direction, I have 1000 newtons that is being applied, and into the static structural analysis, I have a fixed support and I have the force that I have here. So again, we'll go back. I'm going to keep repeating, so make sure you remember the sequence of it. A geometry is defined, material is defined, mesh is done. I apply the fixtures or boundary condition, I apply the appropriate load. Now I need to tell the software what kind of analysis I want to do and what kind of results I'm looking for. So it's a static structural analysis, which I told the software. However, in terms of solution, right click on that and click on insert and tell the software, for instance, we want to have a deformation and I want to get a total deformation. You can see the total deformation will appear here. Let's go to the solutions and bring the stress and get the von Mises, the equivalent von Mises stress here. So these are the two basic results that I'm looking for. Once everything is defined, what you need to do, you need to click on solve. So what it does, it will enable the Ansys solver, go and load it, which basically you can see the solver is trying to solve it. It goes to the main brain of the FEA solver, try to calculate for you, and depends on how complex geometry you have, it might take longer. For instance, here is really simple, it shouldn't take that long, but if you have a really complex model, sometimes it takes few days, few weeks, or even few months, depends on how much computer you're looking for and how much computer power you're looking for, what's the quality of size of the mesh, what's the geometry you have, what kind of support, what kind of loads you have, it might take longer. So let's wait for it and let's see how it works. I'm gonna pause the video and come back once the result is ready. Great, once the solution went through and the Ansys solved the the statistical analysis we had, you will get the result something like this. If I move between the total deformation and equivalent stress, the one misses, you will see the graphs in here will then change. Let's start by the total deformation. So the blue, as you can see here, represents no change, no deformation here as a 0 millimeter. Of course, because I pull it from there, I will have the maximum. Here is a 0.004 millimeter, which basically is negligible in here. If I want to change the contours, what I can come, if I go to the display, if I go to the smooth contours, you can see I will get the much more smoother contours. If I go to the contour bands, I will get the bands between them. So if in case I want to analyze it, I know that's the area, that's the maximum deformation I have there. So I have to concentrate there. If I go to ISO lines, I get them as lines. This is what I personally really use. And also if I go with the solid fill, you can see that's basically, I don't see any lines here. So let's go back to the contours. Even in here, I can go with a no wireframe. So I don't see any mesh. I don't see any basically wireframe, no edges. If I go to the under Based on the form, I can see the difference between on the form and what I have here as a deform model. If I go to the only on the form model, you can see that's the on the form become like a transparent, and the deform one I will see on top of that. And if I go to the show elements, I will see basically the mesh on top of the model. So it depends on what you want to do. You will have the different options to work with it. So let's go back to the equivalent stress, and you will see I have 17.73 megapascal stress, but basically if I zoom in, you will see that's in these two areas because the model is pulled, and the minimum is 0.6 megapascals in these areas. Same as before, if I go with the contouring, I can go with the smooth contour, I can go with the ISO lines. You can see the regions that basically the stress will then change. Also, I can go with a solid fill. Let's go back to the contour bands. Let's go and see without wireframe. I can see with the undeformed and the deformed model on top of each other. I can also make the undeformed as a transparent, and I can go with the show elements. So in here, I can go and show the minimum and the maximum, basically a stress. And if I use the probe, I can go and find out the exact stress on the different points. You can see whenever I move these probe, it can be the exact value over there. That's really useful if in case, for instance, you wants to get the information between the different areas of the model you have, and that's the probe. The maximum and minimum, because I activated, if I go back to the total deformation, also I get the minimum deformation and maximum deformation in millimeter in here. Again, if I click on the probe, I can go and get the different values on top of the model. The other thing I wanted to mention, if I want if I want to basically play an animation into the graph, if I click on play, you can see I get a really good basic animation that's really useful for the presentation. Basically, it shows the deformations. If I go to the total deformation here, and you can see the changes in terms of the deformation in millimeter, and also the von Mises equivalent stress in here. If I want to save that video, I can click here and export the video in whatever format that I want. You can have it as MP4, WMV. I can have it as a GIF, which is really useful for the presentation on .avi as well. The other thing I wanted to mention, let's say sometimes you want to get, for instance, a section view. What you need to do, you need to go to the section plane, click here, and if I drag the mouse, I can have an imaginary cutter and section the model. You can see that's basically the section view of the model. If I want to bring back the full view, I need to click on the section plane, drag the line, and show me the full basically view. If I want to save this one, the figure, what I can do, I can go to image, and it says image to file. What it does, I can save this one to the computer as a PNG file or JPEG and so on, which is really useful if in case you want to provide a report. Also, what I personally do use, if you go to the equivalent stress, right click and click on export, and let's say Ansys viewer file. The benefits of using this one, let me show it to you. If I go to this PC, let's say here, and let's say desktop, I can call it file. That's absolutely fine. Now, if I go back to that folder, and open it up, that would be really useful for whenever you want to basically to just show your model to a line manager, to your colleague, and discuss about it. You don't need to always open the Ansys. This file would be fine, even you don't mess up while changing the criterias, loads, everything, because if you go back with the main one, you can always change it. But here basically is like a viewer option, which you can see that it's like the software. I can use the probe, I can zoom in, I can basically use the cut plane and then cut the model, for instance, and so on. That's a really useful tool, to be honest, to just use it for presentation. Let me go back here to the model. We discussed about the animations, the different contouring and edges, minimum maximum props, save to image, section planes, save. Let me see whether I want to add anything else here. I think that's fine. I think we covered the majority of these. The other thing, if in case you want to play with the coloring here, if you click with the plus, you can see the range become much more wider. That would be better. For instance, I can minimize the range or I can maximize the range. Depends on what sort of criteria you're looking for. Even you can work with these, that they are really useful. Okay, so that was it for today. Hopefully you learn about how to run a really simple FEA on the Ansys. So if you have a much more complex model, again, the criteria in here will then change, but the rest of it is the same as it is. You will have a geometry, you define the material, you apply the meshing. You might have a local meshing. So if you click on a mesh, probably you need to work with a different type of the mesh here. If you go to basically a structural, you might need to have the different type of forces, different type of support, and also in here you might probably need the other kind of analysis result. But the rest of it is the same as what we've done so far, and is exactly what we've done. The other thing I wanted to quickly mention, that whenever we just said, if you remember, comparing the undeformed uh, with the actual model, and if I play this video, what you will see basically here, let me activate the elements and then compare it. It's somehow like exaggerated deformation. And how can I check that and compare with the real one basically in here? So that's the same thing. Even if I go with the total deformation, if I compare that, you will be able to see it here. So if I go back basically to the comparing the undeformed with the deformed, is regarding that area. So by default, it used the exaggerated. It apply a factor of safety to that. That factor of safety is, for instance, if you have the result, usually use a 10%, 20%, or sometimes even 100% factor of safety, that in case that if you're fine with the result, that you either double it or you add 20% to make sure it's safe. That's why the auto scale has been applied. But if I convert it to a scale, what you will see, basically I don't have that many differences here, because the only information I have is a 0.004, which is negligible. It's really hard to even see it. Same thing, even if I go with a stress, it's basically it's something that actually will be visible with the naked eyes. So again, as I said, that's, in order to see it, it's a true scale. But if in case you want to see that, what's happened if I increase it but 2 times or 5 times of the auto scale, I can basically control it here to just see that how it looks like, to just represent the deformation. Great, thank you so much for your time, and please keep in touch with me if you have any question. Thank you. That's Esfandiar Kolgi. Take care. Bye bye.